come over on the stage.
Can you take a few questions?
Yeah.
As I always say, you can ask questions, I don't guarantee I will answer. Okay, go ahead. What's the question? Where is the question?
My question is that with your considerable experience in this and this discovery having come, what do you see as the future of research and collaborative research? And what role will Indian institutions, the Pune institution that you referred to, play in the endeavors of the course?
Okay. First thing is, what will all this gravitational wave detection do? Is, for example, it opens a new window in the sense, many events like this, black holes colliding and all that, may not be amenable to optical observations. Huge amounts are done in optical, but certain things may not be, and the gravitational wave will do that. The most important thing in the gravitational wave detection is this. In the early universe, when the Big Bang occurred, by the way, you know, there was a Fred Hoyle and Bondi and Tommy Gold. They gave the steady state theory, which did not hold water because because of the background radiation, they could not explain. But at the time when both were viable, Hoyle denigrated the other model, saying, "Oh, singularity, Big Bang," he said. But he said it in a denigrating manner. But it caught on. So now we say Big Bang, okay. And so when the Big Bang occurred, immediately the universe was filled with plasma. And the light does not go through plasma. Only when it expanded and galaxies came into existence, then optically you can see that. But what was happening in the early universe, when light could not escape, only gravity waves that come through can tell you. So when gravity wave detectors become so sophisticated as optical ones, it will tell you what was happening right in the moment, after a millisecond or microsecond after the Big Bang. That's very important for research. Now, the Indian component. There are two people, Professor Balaya and here in Bangalore at Raman Research Institute. Professor Iyer, I was in Raman Research Institute for 76 to 92. For 12 years, Professor Balaya worked with me. I take pride in that, and we wrote 12 papers together. And Sanjeev Durandar, who is an IUCA, he worked with me for 2 years and we wrote 7 papers. So these are all, younger generation with whom I was very happy to work with. But then they went on to gravitational radiation and they did lot of theoretical calculations. And if you look at the PRL paper, there are 1,000 co-authors, and out of which 35 in India and about another 15 or so Indian origin people outside the country. They all put in the theoretical things, and also some of them worked on the LIGO hardware also. So that they were all not working for 30 years. For at least 15 to 20 years they have been feeding all the theoretical things for this going around, merging at that stage and all that. One is production of gravitational waves, Balaya was doing, and Durandar was doing how to look at it. It's very sophisticated because you have to build what they call templates. What you get is garbled. But only if you put a template and filter, then you will see what you are looking for. It's like filter is like making tea. When you make tea, which I love tea and I make it myself, you put the tea powder and all that, what you get is completely garbled because tea powder is there and pure decoction is there. Only when you filter it, the tea powder which you don't need, tea leaves, that's like the noise, that goes away. And the decoction which you want to drink, that's after the filter, what you need like quasi-normal modes, you get that. So Sanjeev Durandar was building templates. So Balayar, my old colleague, was generating gravitational radiation, and Durandar was building templates to see them. I used to ask them, why did you have to spend $1 billion to build LIGO? Between the two, you generate and he observes. Why 8 billion? By the way, the $1 billion were given from National Science Foundation by my colleague. He and I worked together with Charles Missner. His name is Richard Isaacson. He was the one who gave. And in the first one when they announced, he is sitting right in the front second row with a shiny bald head. And he wrote to me, Vishu, you please look at that. I am illuminate LIGO with my bald head. So we have to, one great thing that happened to me was, so many of my old friends wrote to me. We became close once again. So now, I haven't answered the question, sorry. So now they want to bring, this is Indigo, they want to bring the LIGO from US to here. So America is ready to give a clone of what they have. They are not going to give that, but the exact replica of that to India, so that it will cost 1,260 crore rupees. Many scams, so for more than that, so it's all right. But it will take a long time. So you need younger generation. Maybe they are not born yet, but they will have to be trained, hardware, software, hardwares and so on. So they are all working on that. And in that Balayar and Durandar, Ajit Kembavi, they are all, they agree that they are all my bache. Okay, they are all working and hopefully it will work someday.
Sir, do you see any practical applications in day-to-day life?
This is a question which is asked always, and yesterday in the press conference also it was answered. There are two answers to that. When Faraday found electricity, somebody, I think it was Faraday, I don't know, Disraeli or somebody asked what's the use of this. He said, sir, someday you will be able to tax it. So today, KEB or whatever, they charge us, right? And they give you these bulbs, LED, so that the consumption goes down. So, that is one. Another thing is, whenever you have technology, space technology, what's the use of that? Every technology has a spin-off. They manufacture things, they create things that they come into everyday use. So you ask the space scientists, they will rattle off so many things that has percolated into our daily life. I don't know those things, I'm sure there are a lot of things. Even space, NASA said the epoxy they had to create became extremely popular, used super glue and all that, okay? And Einstein, supreme example. When Einstein gave his theory of general relativity, purely theoretical, what's the use? But your GPS uses general relativistic correction. If you use GPS and wanted to come to MES college, if there were no GPS correction, you would have ended in Central College. And you wouldn't have been able to, or in the pub somewhere. You would have had a nicer time in a pub than anyway. Okay, now that is one. And then somebody asked black hole research about the galaxies, universe expanding. Somebody asked Chandrasekhar, what is the use for the human beings, humans? So Chandrasekhar gave the most profound answer. It helps the humans to remain human, to have the experience. You know, how are we human? Because of our curiosity, the inspiration. Why do you enjoy poetry? Why do you enjoy music? We won't spend that much money. We may have to spend that much money to keep, the inspiration and the drive kindled. You know that. And we are human. That's the other one. Okay?
So, one small question. Since we are in the college atmosphere, how was your student days, and were you a hard-working student or an intelligent student?
You want me to confess? I will confess with a little boasting. Okay. What happened was, all our education, I am taking too long, I don't know. You cannot go away, I will talk. The great Shankaracharya went to Mahishmati. What century was that? 9th century or whatever. Looking for Mandana Mishra's house, because he wanted to have a debate with the Mandana Mishra and Purva Mimamsa and Uttara Mimamsa and all that. And he asked me, how can I find some passerby? They said, very easy, Vendrated sir. If you go there, even the parrots in front were hanging from Mandana Mishra's house will be reciting the Veda. Beautiful. Works for Veda does not work for science. You can't learn science by rote as you learn Veda and then repeat it. But that's what we are made to do in science education. I got 3 gold medals in BSc Honours. I'm ready. Wait, don't. This is something you should not, really, I'm serious. I'm ready to throw away those gold medals because everything I wrote and one was by rote. I did not, one of the questions that was asked, derive Stokes' law. Eta, 6 pi eta, whatever. I had memorized it so that I could write it in 20 minutes flat. World record broken, and I did not understand a single step I had learned. When I went to Columbia University, I went there thinking I knew everything. First day I was demolished because my professor said, solve this problem, assignment. Everybody solved, I didn't know how to solve. Why? Because I had been trained to memorize and write back. So, fortunately, and when I went to PUC or intermediate, Dr. H.N., I used to play table tennis, and H.N. used to come ಬಂದ್ಬಿಟ್ಟು ಯಾಕಪ್ಪ ಏನಪ್ಪ ಮಾಡ್ತಿದ್ದೀವಿ, that's how we used to say, ವಿಶ್ವೇಶ್ವರ ಮನೆಗೆ ಹೋಗಪ್ಪ ನೀನು, ಮನೆಗೆ ಹೋಗಿ ಓದು ನೀನು ಚೆನ್ನಾಗಿ, ನಿನಗೆ 75% ಬಂದ್ಬಿಟ್ರೆ ಎಂಜಿನಿಯರಿಂಗ್ ಕೊಟ್ಕೋಗ್ಬಿಡ್ಬೋದು ನೀನು, ಹೋಗು ಇರ್ಲಿ ಸರ್ ನಾ ಹೋಗ್ತೀನಿ. But I used to love learning mathematics and physics. I just learnt it not for exam. I learnt it for my pleasure. But lo and behold, one day I was very drowsy after food and I wanted to sleep. One of my friends, he came and said, HN has gone mad. You immediately come. I said, if he goes mad, let him go mad. I want to take my nap. He said, no, you have to come. And I said, he was really saying, ವಿದ್ಯಾರ್ಥಿ ಅಂದರೆ ಹೀಗೆ ಬೇಕಪ್ಪ, ಏನಾಯ್ತು ಸರ್, ಅನೌನ್ಸ್ ಆಗಿದೆಯಪ್ಪ ನಿನಗೆ 3rd ರ್ಯಾಂಕು 95% ಬಂದು, ಇವಾಗೆಲ್ಲ 98.9997 decimal place people take that, right? In those days 95% was the record. ಸೊ ಈ ಥರ ಜಂಬ ಹೊಡ್ಕೊತಿದ್ದೀನಿ ಅಂತ ಅನ್ಕೋಬೇಡಿ, ಯಾಕೆಂದರೆ ಜಂಬ ಹೊಡ್ಕೋತಾ ಇದ್ದೀನಿ. ಅದು ಆ ಥರ ಆಗಿದ್ದರಿಂದ ಐ ವಾಸ್ ವೆರಿ ಹ್ಯಾಪಿ. ಆ್ಯಂಡ್ ಬಟ್ ಐ ಫರ್ಗಾಟ್ ದ್ಯಾಟ್. ಸೊ MSc ಎಲ್ಲ ತಿರುಗಿ ಇವರು ಹೊಡೆಯೋದು. When I went to Columbia University, I realized we learn nothing unless you solve problems. That's why in the planetarium we have the what we call, it's a very structured educational program for children of primary and middle school. They come and play with science, with colors, with light. They make little gadgets, pinhole camera, little microscope. They are inspired. This is, I call this science education in early development. If you take the acronym, it says SEED. Then high school students come more structured, they solve problems, they do experiments. This is called science on weekends, SOW. So, and then BSc 3 years. First year they study again solve problems, otherwise you don't learn. Basics. Second year, and the teachers are all from premier institutions like RRI, IAA, ISC and so on. And second year more advanced. Third year, with the same mentors, they do research problems and many of them write papers. This is called Research Education Advancement Program, REAP. So we have seed, sow, reap. So we have at the planetarium the tree of learning. So I do have hope. Students from MES College and all that, Bala here and one Professor Lokanathan, legendary teacher, they used to teach religiously, even though Bala here teaches there. So if anybody, students come there, and one other thing, somebody asked your question, MES College should take pride. You know why? 10 years ago or so, Bala years took about 5-10 students from MES College, started teaching them, made them solve problems. That is why the idea germinated, and I said to Bala, let us do it in a big way. Started at the planetarium and it thrived and we have reaped. So it started all in MES College. Now we can.
Thank you, sir.